Welcome, I'm Bill Wake. We're working on a project called Fiume. It's a program to manage streams and pools of money. And we went last week from a simple list of streams to more like a tree of streams. And along the way, we noticed our graph is not really quite graphing what we want. So we're going to deal with that today. And then we're also going to move into the combinatorics side of things. What happens if you have a plan with lots of alternatives and alternatives stacked on alternatives? Then you start getting into the combinatorics, where combinations, they kind of multiply. All right. So this is back to kind of three key models we're working with so far. So the first is an and or tree, and we got that going last week. Basically, for us, most nodes are and nodes, which means the children, well, the and children must all be present. In our case, all the nodes, all the children of one node are the same, but in this picture they can be different. But in any case, if we had P and Q and R are required, then they're going to be there. But if Q has T and U are optional, in our case, only one of them is going to be there. They're more like mutually exclusive. And so you get combinations of these things possible. What are the possible trees? Well, it's going to be P and it's going to be Q and it's going to be R. And then it can be either T or U. And then if it's not Q and R, it's going to be S. Okay, so it's almost, well, I don't know if it's quite a regular expression, but it's getting close if it's not. All right, and then the notion of combinatorics says, well, part of combinatorics, it's a big area in math, but if you have, 4 choices for the first thing and 3 for the second one, then you've got 12 combinations. Black square with red, with greenish, with purple, orangish yellowy square with red, green, and purple, and so on. You get 12 combinations, and they multiply rapidly. Now, in our case, I would think about 100 combinations would be about the most we want to look at a time. Otherwise, you kind of can't make sense of it. But that's, we'll see when we get there. All right, and then the third thing is the notion of panes of glass. And this says if you have something, you can update part of it, and that will show through, and the rest will be transparent. And so you'll see what was there before. So the yellow, and you stack a half transparent red on there and a half transparent blue, you can still see some yellow in the top left corner, and you can see red in the bottom left corner because those two are showing through on the clear part of the blue and possibly the red. All right, and so for us, we have that because we want to be able to enter information like my salary is $10,000 a month. Like I said, we're going to be generous to ourselves. Maybe make it 20. Okay, so $20,000 a month salary. And at first, we haven't specified what the date range is. Well, we could then say, well, it's starting now, and then later come in and say, well, until I retire, which maybe is going to be age 67. All right, and so altogether, that adds up to $20,000 a month from now until age 67, but there's no single thing that contains all that. Okay, so those three things kind of come together to make what I think of as the new thing we're bringing in with this, the new looking at alternatives. And so I don't know, I try not to code anything on our stuff outside of what we're doing, but I do think about it a lot. And what I'm thinking now is we're going to have the notion of concrete plans. So we have, I guess it's an abstract plan. We haven't called it that, but you have a sort of total plan that's like, here's this plus maybe these alternatives plus maybe some more alternatives plus some other stuff. That represents a lot of plans because of the combinatorics. So I think what we're going to do is find a way to take the master plan or the abstract plan and identify the possible combinations. Each of those combinations will be a concrete plan. What if you chose this and this? Okay, that's the end result of the plan. And so I think one abstract plan is going to become multiple concrete plans if you have multiple scenarios. And then the other thing that comes on is the notion of streams. If you have a stream and another stream is stacked on top of it, we have that panes of glass idea. We need something to merge a stream into a more complete stream. Do we need to distinguish stream factoids from whole streams? That's a thing I don't know. Right now, our streams have a little bit of optional information because they don't make you to specify the start date and the end date. But we'll have to make sure how that assembles together. It's a little tricky for sure. But I also think what I'm getting to is there's sort of the notion, there's the notion of a partial stream specification and a full stream specification. And the concrete plan needs full stream specifications. Okay. So our concrete plan, we'll probably get to implementing that today, but my notion is we'll add streams to it and we'll ask them for the net for a given month, and we'll probably need to iterate over them too. All right. You're allowed to think like you're able to stop. Are you saying on the salary one that you could add a stop to it? Yeah. All right. Now the graph, I think I even found what the problem is if I can get there. Our stream, right. Yeah, our stream tells us how much money do you make in a particular month. You give us the month number, we'll tell you the money for that stream. All right. And it looks at the first and the last and it's checking for nil and all that. And I think some of that needs to be more abstract, but that's not where we are. But anyway, stream calculates it. But if we can find our graph, let's see. I guess just look for graph. It doesn't call it. Bug and graph, thank you. How is that not a thing? All right, let's get over here. Maybe scenarios view. That's a form. Maybe it's just content view. Oh, it's a chart, not a graph. Okay. And the chart is based on plan.project. Okay. Okay, so for each month, we get plan contents. Well, I thought I knew what was going on, but I don't. Oh, yes. Yeah, unfortunately, I have to. Thinking doesn't stop. Not always good thinking. You can get ahead of yourself. Well, where is that little object? I mean, somewhere we define, yeah, net worth data. Okay, who's producing that? Right. Plan contents of net. Okay, so, I should run it and show what I'm talking about. What we'll see is a line that starts at month 1 and goes for the whole distance, even if you said it was going to start at month 12. Okay, so it's clearly not looking at things. Now this plancontents.net. Okay, children.reduce money, add item. His type should be stream, I think. Oh, it was a plan tree. All right, let's go back to plan tree. Come on. Here we go. Net. PlanLeaf. Yeah. PlanLeaf is the leaves of our tree, which right now are only streams. Eventually they'll be pools, and we may distinguish in streams and outgoing streams. Okay, but yeah, here this is taking stream.monthly amount, but that that doesn't fit. Stream monthly amount is the amount we set up for it, but oh, come on. We really want to know the amount per month. Okay, so we will we'll demo that and then test it. Let's see if I can get this over on the other screen. Make it a little handier over here. Let's close that. Okay, so we'll add a stream. Now notice you can specify the amount. I don't know if that's a required thing or not. Let's give ourselves 3,000 a month. We'll start in month 12, we'll end in month 24, and create it. And here's our graph starting in 0 and going till 120. Okay. Now, what I think has gone haywire is our tree. Right, that this is erroneous. So somewhere there's a test for that. PlanLeaf. Okay, yeah, we took a too trivial case here. We just created money with a certain amount of income and didn't check something in the range or out of the range. Leaf.net for month 3. Okay, so let's make this test harder. Let's make it let's make it month 3 through 12. Okay, so really, make leaf takes an amount. Okay. I guess we can make that first. Okay, so now we're making this. If we were to check 2, it should be 0. And 13. Oops. Okay, should be 0. Should be 0. Okay. PlanLeaf. Let's break this part out a little bit. All right, so we're on tests. Good. I mean, good that it failed in the way we expected. Not so good that it failed, period. Okay, so let's get up to PlanLeaf. All right, and we said, well, the problem is we didn't delegate to stream properly. Stream dot amount for month. Okay. Now those tests should pass. .01 seconds. 0.17 seemed longer. All right. And we'll commit that. Make PlanLeaf delegate to stream to determine amount in month. I don't think that's an improvement. I would love to. Well, I miss there was a plugin in IntelliJ that lets you just say check in if you're green, you know, or check in. Yeah, so I would rather have that, not to tell anybody anything. I'd also like it combined because if it detects automatic refactorings, it should just say, here's the stuff you did, you know. All right. Anyway, let's run this, see it, make myself a little happier. I don't know. I feel like we had this working at one point, so I think maybe moving it into the tree, I didn't delegate properly, maybe. But all right. So we got salary, $20,000 a month. That can be better. Starts in month 12, ends 24. Well, let's make it 48. I'm going to put two things in here so we can see the band. Yeah, it's already better. And notice what happens. I should say that. 12 months of nothing, and then we're adding. Up to here, it stops adding because the month 48, no more salary, but we haven't spent anything, so we're doing pretty good. Okay, I wish. Okay, let's make this salary 2. Let's make it 5,000. And starts in month 36 and doesn't end. Okay, now we get more. Okay, so the first bend in the curve comes, well, 0 to something. I don't know, it looks a little bent there. I guess month 48. Okay, so yeah, month 36, there's a little bend here as we go up. And then it goes forever, so we keep adding 5,000 a month. Good work if you can get it. All right. Anyway, that makes me smile. That's more like it. All right. Now, I also notice, like, there's all these, what if I created two things named salary? Well, now they're not supposed to be about two different ones. They're supposed to be about the same one. And we don't enforce any of that yet. Okay, but we will. All right, so let's see. We got our to-do. I don't need those up there either, honestly. All right, we did this. Make net for stream only takes archives. Okay, yep. Graphs and combinatorics. Okay. Make trees, unique ID. Yeah, it's not our. It's definitely a thing, but I don't want to mess with it right now. Okay, so turn a plan with alternatives. Yeah, and where that shows up is if you use the same name twice, then the tree management or list management doesn't quite know which one it's talking about and all that, and so it's not happy. But that's okay. I want to move forward. Yeah, forever we limit to whatever. I think there's probably going to be there's going to be a control for that at some point. 120 months is 10 years. It's probably reasonable to look out for 30 years at some point, and then maybe 10 to 20 might be a more normal thing. I mean, if you're in your 60s, 30 years is you're in your 90s. You're not going to look out 50 years, at least not the way things are now. Okay, but I do want to get this. So that was this concrete plan idea. Well, maybe I should rename my plan and make it abstract plan. I think this thing is an abstract plan. So let's do that. Abstract plan. Now, abstract is not saying this is an abstract class. I don't even know if Swift does things that way, but it's more our plan. Oh, 120 years. Yeah, I'm pretty sure most of us won't last that long. At least most of our ancestors didn't. Okay, make sure this runs okay. I suppose I should make this thing abstract plan, not abstract tree. Okay, did it change the test? Okay, good. I'm just making sure the stuff reads okay. We still know it's a tree, but I'm okay. All right, make sure that's green. Oh, what's plan? Oh, maybe I've just messed this up. I mean, the plan, so. Oh, we haven't removed streams yet. Okay, that's another thing to do. Let's add that to the list. Plan. Okay, I think trying to get these names right. Plan tree was probably okay. Now this, a plan. Okay, let's put this back to a plan tree. Okay. But plan, I want to be abstract plan. Unless we can come up with a better word for abstract. But concrete sounds good to me for the other one, for the new one. Okay, let's try it. I mean, another word for abstract might be virtual. I could see it being a complex plan. Maybe it's, I don't know, combinatorial is kind of a tough word to talk to in computer science. I mean, it's just a lot of syllables. It's the right word mathematically. All right. Okay, so make sure tests run and yeah, I know. I mean, abstract as a computer science term would be more about a class that doesn't define all the methods it needs. So how about multiple scenarios plan? I think that's extracting what the real multi scenario. That's probably okay. Yeah, I think abstract's just going to get us burned at some point. All right. Multi-scenario plan. Okay, so this is where we're putting the ones with the and or tree. All right, now I don't know. I think what I want to do, let's create a concrete plan. You can add, you can get the net for a month. Um, well, maybe stream merging. Maybe that's the place to start. Theoretical. Yeah, it's almost like not a plan, right? I mean, it's really an exploration of alternatives. If if it has no alternative scenarios, then it really is kind of a plan. Although we haven't done the panes of glass thing, but um, maybe this step is the right step. Sorry, the stream is the low level thing going on. Let's merge a stream. Yeah, I think that's what I want. All right. Now, I think our stream may be a little too, it's a little too arbitrary. The Rept, welcome back. Nice to see you, and thanks for subscribing. Appreciate that a lot. Let's see. I don't know if you're just speaking up or if you just got here, but we're working on a finance planning thing, personal finance. And the idea is you have pools of money and streams of money. And we're trying to set up scenarios where you could say, like Social Security for US, you can retire at 62, or you can collect Social Security at 62, 67, or 70. And you get kind of three different amounts. They start at different years and all that kind of stuff. And I'd like to be able to say, like, put mine in, put my wife's in, and then we'd have nine combinations of plans and be able to say, like, well, would we be better off waiting for hers or waiting for mine, or how would that work? What if one of us died? All that kind of stuff. Gosh, I get twinges when I say it, but, like, it's a thing to face. You might die. Yeah. Or at least half face. Okay. So what we did so far, we start off with a list of streams of money. We haven't dealt with pools of money at all yet. And then we set them up as and or trees. So either it's just stuff you're going to have, streams coming in, or you're looking at scenarios for the or trees. And the problem is, if you've got this tree of possible scenarios, like I mentioned, the three for me, three for my wife, that's nine scenarios. It's hard to say, take these nine scenarios and graph them. But I think what we'll do is we're going to say we've got this abstract version, or multi-scenario plan, and we will generate a list of nine concrete plans. And then each concrete plan we can accept or reject and graph and not graph and all that stuff. All right. So the first thing in that is we want the notion of a stream. Boy, I almost feel like the name is there, but maybe money should be optional too, and month number. But I wanted to find a merge. So I don't know if I have, oh, we do have a stream. Okay. So the notion we want is a merge. And if I put in a salary and say $10,000 a month, and starts in month one, now normally it's going to end at some point when I retire. Or at least stop collecting a salary. It would be helpful to be able to start by saying that amount, and then later come in and say, oh, now what if I retire at this age? Stop that amount on my retirement age. And so I want to be able to take the salary that came first and the salary that came second and kind of merge them and say, okay, I have a salary that starts in month one, ends at age 62, or starts at month one, ends at age 67, and so on. All right. And to do that, first step, I'm going to say, how do we merge streams? And well, now what this revealed to me is the money, we can't change the money when you do that. Or, well, it's going to be confusing. And maybe we should be able to not specify the money for the salary and then come in later and say, what if I'm looking at three different jobs? This one pays more, but I get less benefits or whatever like that. I might not want to fill in that salary on the rest of my planning until I've made a decision which job is right. So I don't know, but for now, well, the one thing we definitely can merge, we can override these things. I think that's what we want to show. All right. So So our pattern is kind of verb in context. Merge when months change. All right, we'll do two with one blow here. Okay, so let's make a sample, a stream. Well, I guess I could call it stream one because we're going to merge two streams. Sample with money 1,000. Yeah, it's going to complain. Let's make it short and sweet. 500, a little bit easier. Okay, first one, last 10. All right, now stream two, I'm going to change those dates. It's weird that the salary's still there, though. All right, so let's overlap it a little bit. 5. Okay, so what I should get when I say stream one, new stream, well, merged stream, merged equals stream one dot merge with stream two. Doesn't exist yet. And now the money, yeah, I think it should be multiple possibilities. I think making it optional is kind of a cheap way out at this point, because I really think you should say like unspecified end or unspecified start, or you know, something based on the year, or something based on the age, or something based on whatever. Okay, but at any rate, we do require money. Well, okay, let's just say values change. I want this to be an override. Yeah, so the result of this, well, I don't have a stream equality yet, do I? That would seem like a good idea. What the effect of this should be, I mean, this is overriding sample. So the effect of this should be merged is equal to stream of sample with money 1,000, first 5, last 20. Okay. And so in our system, we're going to keep the merged value, building up the concrete plan. We're going to apply these panes of glass and get this view down onto what's the current understanding of this thing. Okay, so global conform to equatable. Okay, so kind of two things. Let's get the, well, yeah, let's get equatable in there. You're supposed to offer to fix it. Okay, thank you. Okay, so let's say LHS.name equals RHS.name and LHS.monthly amount equals RHS.monthly amount and LHS.first equals RHS.first and LHS.last equals, should this be a class? Let's get it together and then we'll decide. Okay, so cheap implementation, or boring implementation. UUID is not in there though, so it's definitely a different notion of equality. And then we have a monk merge takes a stream. I'll say other is a stream, returns a stream. Okay, and let's return, oh, let's just return self for now. Okay, don't do anything. Okay. Keep the first month at 500 sample. Well, that's a real good question. Like for now, so for now, I'm gonna say we replace the value. But I do think this is an area that's a little funny. And it might be, I mean, I can imagine a payment stream like some sort of balloon payment loan. You know, the first 48 months, the payment's really low. And then after that, it gets really high. It's really the same loan, but they shift the way you've got to do it. But yeah, I'm just trying for the pane of glass on this thing. I mean, mostly I think that notion of when do you terminate and it relies on some other thing to know. That seems like you just want to replace that stuff. I almost think you don't want to talk about monthly amount. Well, I don't know. There's so many different ways of doing these financial things. Like, how would you know if you said then the last month is now 24? Are you trying to say here's a new balance for those months to 24? Or are you saying no, the original one ends in 24? So there's this a little bit of ambiguity in what's going on there. Now, maybe there's a concept that I don't know. Maybe there's a concept that you can't replace existing things. Like if you say it's unspecified, it's fine if you specify it. But if you say it's month 12 and now you say it's month 20, like, is that sensible? But I guess it could be. You could talk somebody into paying you an extra 8 months of payments for something, I guess. Yeah. So, well, let's see a failing test anyway. No, I'm totally putting off interest because I think well, I think it mostly applies to pools, right? Because like a loan is a pool, the amount you're paying, sorry, the actual loan, you know, you borrow $1 million for your mansion or your mini mansion or whatever it is. You borrow that and then that pool keeps growing. Now, on the other hand, there's this payment stream that's paying against it. And if you were to miss a payment, well, you'd have more interest on it and that would come in. But it's not interest on the payment, it's really interest on the loan that you're paying off with. So it's kind of why I'm willing to segregate it at this point. All right, well, merge. Yeah, this thing's going to say 110 for 500. Oh, it would be nice if they just said. So Ted Young has some good riffs on making your tests really talk. And like this one is not so well at this point. It's the test is saying, well, the problem is this stream is not equal to that stream, right? It doesn't give us the information. So let's address that. And I don't know, I kind of hold off sometimes on these. It's easy for me to skip some of that, but I think it's a good habit to do it. So let's make stream be a custom debug string convertible. Var, is it debug description? And that is stream. Well, no, we're not running. Self dot amount. Oh, name. That's a little noisy. I guess I can do that. Okay. That maybe, well, again, I think that subject should change. Okay, so we'll see if we can get this test to talk to us better. Stream sample 500, 1, optional 10. Is not equal to 5, optional 20. Well, that describing is a little bit awkward. No, it's not going to take that. Well, maybe I'll say that was good enough. Or maybe take this out and see what we get besides a warning. I don't think it's... I don't like the warnings. And truth be told, I don't like the way that looks. Okay, so let's fix it. Okay, let last string equal I don't know, is there a... Yeah, I think we will... would that be... Maybe that would look better. Yeah, what's the problem? Oh. Okay. Oh, shouldn't have dollar signs. Ah. You're saying maybe a month? Yeah, I think that'll be better. Take off these dollar signs. And the extra 5 minutes to make the test look good for while it's wrong. But I don't think it's unreasonable. And that explanation, maybe we can make that better. Stream sample 500 months 1 through 10 is not equal to stream sample 1000 months 5 through 20. Okay, that's a good failure. All right, yeah, they're not dollars. I don't know why I had dollar signs on them. Okay, let's fix stream now. So we've got merge. You know, sometimes I do this is pull this out. Well, no, it's okay. It's not that much. Okay. Merge, right. So the we've got other, well, the way we are now, we define this and this, well, these three, and then last depends on that. So could you undefine it? I guess you could. All right. But if first Yeah, this is all right. Let's get it working, and then now you don't want to just take the other stream's value. Or do you? The way we are now, you almost do. Well, I think last month is the only one that's really properly overridable. Um, yeah, you're right. I should probably do that. But let's just return other for now, because I think that's kind of the effect. I guess the question is, if you said it was nil, there's a difference between I haven't defined this and I want it to just keep going. Now, if you gave it to us and said I haven't defined it, we could give it defaults, but it still hasn't been. It's explicitly undefined. And then if that were the case, then you came in and said the month, the end month is now undefined. I don't know. Something should be showing through on the pane of glass, though. That's the part I'm getting. Right. Well, I think the way it is now, this will pass. Okay. And so that's showing me there's not really panes of glass going on yet. And that comes back to we haven't we don't have enough choices for these month numbers. Like what does nil mean? I guess it's undefined, right? And I don't know. I could see us having a rule that says, like, if it's field's defined, you can't override it. That shines through. But that's not right either, because if you said, I defined it for 30 and now I want it 40, like 40 should prevail. But maybe you want to leave the first month number alone. And so the nil ones, if it's nil, maybe it should show through. Okay. Yeah. So let's get back to our test. Let's get this green and then we'll play with it. Okay, yeah. So I think that's okay. And then I want to say merge when values are omitted. Yeah, that's the one I want to say. Okay, so if this is nil, then these two got overridden, but the last should be 10 still. All right, that's the piece we don't have. Yeah, I think well, this is the problem I have though, that I want to let some things shine through, right? That's this again, this panes of glass thing. There ought to be things that can shine through. If you just want to say when the last date was, then then that's fine. If you want to change the first date, then it seems like, I wanted to change the first date to 5. Well, let's make this 500 again and this 500. So I don't want to change the money, but I'm required to say it, so I have it. But if I wanted to change month 5, I want the start month to be month 5, but the end month is still 10. Okay, so it took me a while to get hired, and now my salary is going to start on the 5th month. Maybe change these numbers just for good luck. All right. It was going to be for a year, but they're still, they didn't start me till May, and they're still going to end my contract in December. That seems accurate for representing that. So I think the thing is, though, that these are our only two possibilities right now. That is not the way it should be. I think one of these, I don't think don't think nil is the best way to express unspecified. And so an update specifies some things and leaves other things unspecified. Like really, I would like to leave money unspecified. I'm not making any more. I'm just going to start later. But that's a required field right now, so it doesn't work that way. All right, and I think I want to move away from nil. I want this to become an enum because I think there's a lot of ways to specify the ending of something. We mentioned, well, month number, year and month, relative to a retirement date, relative to a death date, relative to a birth date, I guess, if it's 62, age 62, or relative to an age. All those are valid explanations of when something should start or end. And so I think this month thing really needs to grow. I guess it's in stream. Just saying there's a month number, oh, it's optional or it's not optional, that's not enough for where I want to go with things. But I think if I have enough to prove the concept that I can show things shining through or not, then I can talk about these concrete plans better. All right, and this, okay, so now we got to think the name. Well, right now is only the last month that we can look at. So if other.last is nil, then we're going to use self.last. Otherwise, we'll use other.last. And then we will make a new stream. Name is self. Well, I'll call it other. Other.name, other.monthly, other.first, and new last. Okay, because that's the only one we've defined that can be overridden. What am I missing? First and last. Okay. Right. Well, that should pass. And I think in the end, like if you got to a plan and it didn't have a defined start date, we would just pick month one. If it doesn't have a defined end date, we'll just pick whatever our last month in our graph is. So I think it will be okay that way. All right. So, well, let's take a to-do. Streams, yeah, okay. So this notion is make more, well, how about refine the notion of start or end date to include unspecified and specified. I think that would be a step forward, and maybe plus year, age, whatever. Okay. So I think this should be, well, make stream have a merge capability. All right. Yeah, the undefined, in a way, I mean, in a way, undefined is really saying take the underlying value, and if it's a later one that leaves something undefined, it really is explicitly going in there. If you get to the end and something's undefined, like if the salary's the amount is undefined, I can't do anything. I'm just going to make it a 0. But start date and end date, I have other values. It makes sense. Okay, so that's good. All right, so, well, it's all kind of part of the same thing, but all right. Make stream able to merge with, well, and this is identically named streams. All right, that's a case we should cover. And this is really don't merge when names differ. Okay, so in this case, we've got a sample and a different sample, a different stream. And like if I'm merging sample with all my children new stream stuff of talking about the sample, or make it salary. And I say merge it with different, then you should just return you should return stream 1. Well, let's make it explicit. 1 and 12. Okay, you could return a new stream with different values, but it should not incorporate anything from different. Okay, so let's just make it totally different. Every field's different. All right, and merging them should just leave us with the original sample. It's the only one that's relevant to a sample merge. I think it's kind of a don't happen thing or a won't happen, but I want to be explicit that we're merging into a stream with value on it. Pretty normal, keeping the precious values with immutable data. Yeah, previous values. Yeah. Yeah, and okay, so let's make this pass. It's failing now, I'm sure. Because we don't look at the name, we just take whatever the new name is. All right. Stream, we pulled in different instead of sample. Salary. Okay. And it's not hard here. We're just saying if self.name not equal other.name, then we're just going to return self. Okay, so we won't merge anything. If that deserves a little space. Okay. All right. Let's commit. Stream only merge when they have the same name. Okay. Good. All right, now let's clean up some. We identified this already. It helps to pull out the equatable. I just don't know if static functions, can they pull out like that? I guess that should be okay. We've done them before. Okay. Okay, now the bigger change I want to look at is I think streams ought to be structs, not classes. They really won't change in our concept. You'll create a stream. I guess you could go back and edit it. So we'll have to deal with editing something in place, but I think they're going to be, the actual instances will mostly not care. But let's try this. This is a little bit of a spike and a little bit of a refactoring. Somebody should be complaining on the edit side. Let's say that. And if that gets too messy, we'll leave it a class. But the way I'm treating it is merging, and it's a new thing. I don't want to change its values. Wow, that worked like that. I think it's not building something. What do I know? Okay, so if oh, we don't have editing yet. That's why. Okay, amount 500. Create. Okay, so we got months. Yeah, this is almost. I almost think that would be a good candidate for maybe that string is the natural representation of this thing. Yeah, we don't have editing. Okay, so it may be that this gets problematic if we want to go edit this one. I think we'll put buttons over here, one for delete, one for edit. We kind of had them at one point, I think, when we had the list. And then maybe that'll have to deal with it. But for now, I think that's actually okay. All right, so make stream be a struct rather than a class. Okay. And I think in general, you're better off. Well, if something is very, if it's struct like this one, I think you're better off being a struct. It's really if you've got shared state is kind of when it's more important that it's a class. If you want two people pointing to it and this one changes it and that one sees it, it's easier. Add an inner salary and see it change. Oh yeah, good point. Well, it won't. Okay, because that's the difference between the multi scenarios. Well, I don't know what it'll do. We don't call merge. It won't change, but we can add it. Right now, it'll duplicate it, which we don't want. Let's give ourselves 1111 per month, starting in month 12. Right? So we're getting two salaries. Wait a minute. What just happened? Salary 1111. It shouldn't be. It should be neither. Honestly, I think. I think this is well. It would be nice if there were some visual indication that something was going on, but I think what's going on. Yeah, this is one of these. I guess I'd call it a shortcut. Let's see if no \name, right? So I said plan sections ID name here. This is how you tell one tree node from another. So I think plan tree. I think he ought to be. I think he ought to be identifiable. No, our leaf. Oh, our leaf is not. Yeah. I don't know if I can make the top level node identifiable, right? Because there's not really storage on a protocol. Right, that's not good. That's normally what I do. Yeah, initial value not allowed. I don't know if I can say it on the children. This is interesting. Okay, I mean, this should be fine so far. Yeah, I want to give these just UUIDs so that it knows which one it's got. I mean, I'm speculating, but I think this is kind of the answer. Okay, but really, I don't know which view I was looking at. This one, plan list view. This would really be better off if it was ID. Are you not going to complain? No, you're going to complain. Outline group requires any form conform. Yeah, that's not helpful. Okay, let's try. Well, let's move this over here. Let's put the ID up here and see what happens. Oh, are you happy now? Okay. Tests are good. Well, I don't think it actually. I'm not sure. All right, let's put that same situation though. Salary 500, well, 5,000, so I can definitely see it. And then we'll add salary 1111, month 12. Okay, we got the bend. Yeah. Okay, so now it's adding them. And that's not really right. I mean, it's right for what we've specified so far. We just say you put in a stream, we add them up. But it's not right for where we're going. Okay. But I think it's okay. I mean, the commitment is, well, okay. I would love to specify iterable up here as well, and I don't think it'll let me. Sorry, identifiable. All right, but maybe. Right, and I don't want to go down that route because it gets ugly fast. But I am saying trees get IDs that are UUIDs. I kind of interpret that. I mean, even if you're not identifiable, like I kind of think you are. Where? Oh, okay. Where ID? Is it like this? Oh, 2 equals? Yeah, he still wants that any stuff. Because he doesn't trust them that they're all the same, I guess. For us, the string is not going to work, right? Because 2 fields will have the same string names. Okay, so I can't have this. Yeah, so But I do have the ID listed as part of your constraint for your protocol. You must provide me an ID. And the children are doing that by becoming identifiable. I think that's okay. Let's make sure. I'll do a build. I must have bumped something else. Let's try a test first. All right, in a run. $500 starting in beginning. Okay, it's growing slowly, and then kicks in. So yeah, it's just adding them up, but that's where we are. I think that's okay. We've created the capability for stream to merge now, but we don't have a mechanism to use it. And the mechanism I want is take the multi-scenario plan, the abstract plan, virtual plan, whatever word we settle on eventually, and turn that into a concrete plan. And the concrete plan only has defined streams. Okay, so let's see. I think yeah, we're not quite doing this one yet, but we make stream a struct. We did that. And this is but not using it yet. Okay. So it's a little, this is a little weird to do, right? I mean, and maybe we should find a way to warn you or something. But I think the difference here is it's probably coming in at 10,500 per month on the later months, and it should be coming in at only 10,000. But that's okay. We'll get these straightened out. All right, but anyway, I want to go on to the concrete plan because I think that's where it's going to make a difference. And I said our concrete plan, we have to add a stream and eventually, so this comes in two phases. So the first phase is we go from the scenario plan, turn it into a concrete plan or a set of concrete plans, and that's going to all be adds. We're just going to add whichever streams apply. For now, if we didn't have the scenario, the org tree part, right, and we just had ands, then we would merge those, add those streams one at a time, merge them as they showed up identical, and develop the concrete plan. And then our graph would say, okay, now we're going to do net plans. Every month I'm going to ask you how much money you have. And based on the streams you contain, we know that. Okay, so a concrete plan really add stream. Yeah, the thing is, we produce it somehow. All right. And I think the way we produce it is walking our tree. And if it ever diverges, we have to make multiple ones. So it's kind of a recursive walk. All right. So I don't know if I want to do the walk. So I think the thing is we're going to walk our multi-scenario plan and produce the concrete plan. So I think we should start with no options, just a list of streams. and have the effect of merging those streams. So we're not going to worry about graphing it yet. We're just going to walk through the plan. Well, on the plan, we're going to walk through the list of it. Well, where's plan? Plan. Wait, where is plan? Is it in here? No. Oh, wait a minute. Multi-scenario plan now. That's the guy. Oh, yeah, let's get rid of these streams. Okay, I think we can. It'll simplify things as we do this. So remove streams from plan. Let's move that up to the top. And it says multi-stream plan. No wonder you can't find it. All right. I still don't see it. Multi-scenario plan. Okay. All right. Now, who's referencing this? Right. So nobody reads it. Let's take this and this. I hope nobody reads it. We'll see. Okay. And just to make sure, sometimes I think the compiler doesn't quite finish building things if you don't actually create a view and run it. Well, it's going to have one stream in it. Right. Good. Okay. Remove dead code, multi-scenario plan dot streams. Okay, now I'm guessing there's a test for this. There does not appear to be. Do we have a plan? Yeah, that should be renamed. A multi-scenario plan. Okay. Yeah, I think that's the way to go. You create a branch, you duplicate. I think you're going to duplicate the concrete plan. Okay. So, did I commit that? Okay, so what? Well, this wherever we were doing. All right, so the first test then. Let's make something with no branches. You know, we don't want to. Let's at least get from the current situation to before we tackle the scenario stuff. So this is concrete plan with no branches, no scenarios, I think we've called them. All right, so let's make a plan. Plan equal multi-scenario plan, plan.add streams. Okay, that's a perfectly good plan. And now we want to say, let concrete plans equal plan.concrete plans. Okay. And then, well, there should only be one. Concrete plans dot count should be 1. And then we should be saying some stuff about more asserts what's in it. All right, but this doesn't exist. All right, so concrete plans. Returns a set of concrete plan, which would be great if we had one. All right, and let's put it here for now. Okay, so that should has to conform to hashable. Is it a set? Yeah, let's add that. And I think the UUID here would be fine. There's nothing that makes them particularly, well, they will be different, but there's nothing that obviously makes them different. Let's try it. Because I could see needing to put these on the screen at some point, or at least track them relative to the screen. So let's give it ID let ID equals UUID. And then down here, equals, let's say, false. Now, that does not convert to hashable. Okay, well, you were going to give me stubs. How weird. That looks a lot more like equatable. Yeah. Okay, we'll just do that for now. Good enough? All right. Test should fail. Not quite that thoroughly. Missing return. Okay. Undefined symbol type metadata accessor. Good. Should be 0. Okay. Well, we can certainly just add 1. That gets us past the hump of that. Okay. So I think his goal is delegate, and we'll add constraints in while we do that. So let's get plan tree close. Maybe I should pull concrete plan out. Yeah, let's do that. I might need foundation. Yep. I don't know what you want to call this. It just only returns 1 empty plan so far. Move concrete plan to its own file. Okay, so I'm more worried about creating them at this point. All right, so creating it, well, it really should be going to its plan trees. Yeah, so sections append, add is plan contents. Make entry my finances. Okay, so right now I think we can just go to plan contents. All right, so plan contents dot concrete plans. Okay, and then well, let's get the conformance first. All right. Okay, this should just be the same. I did. Okay. Now, thinking recursively. Okay. I think we're going to come up against the fact that we don't really know the difference between an and tree and an or tree at this point, and we've gotten away with it so far. So we'll need to address that, and then the actual process of either a leaf contributing to a plan or the the composite owning the plans. All right, so yeah, as you say, it's break time. Let's take a break, and then we'll come back and create an equivalent sort of test over on the plan tree side. All right, see you in a few minutes, 3 or 4 minutes. All right, welcome back. All right, let's see in our tree. So the challenge we have is given either a leaf or a composite node, and if it's an and, we'll pretend that we only have an and node so far for our planning purposes. If if I tell you if I tell you or I ask you for give me the concrete plan based on all your children. All right, then I think what we should do is take the plan. Well, I think we should just add each child in. All right, now, what if it's the leaf, I guess, right? Then we should just add the leaf. We should merge the leaf with whatever plans we have. Okay. Yeah, so this is sort of an accumulating thing. Now, our first test is not going to demonstrate that very much, but I think what's going to happen is, well, maybe even our first test does. All right, let's go to a plan tree. Okay. I don't know if these tests. All right. Let's do concrete plans. Okay, so function test. Oh, I've been doing these, haven't I? I was trying to do snake case test names. All right, so concrete plan for stream. Okay, so I think what we want to do, well, I think really what you're saying is if I give you a stream on its own isn't a plan exactly. I mean, the way we do it, we always have composite plans. Just based on the way we set things up, we start with that my finances with the plus sign, right? That's a composite. Doesn't have anything in it yet, but it will. All right, so I think what we want to say, let's make a leaf. Oh, that didn't take. There we go. All right, so leaf is income 1,000 months 1 through 12. You make me say first and last? No. Okay. Right. Now, if I say make concrete plans, leaf dot concrete plans, well, somebody should capture that. Let result equals. And I guess the plan. Well, I think the thing we're going to say, well, we haven't talked about reading these plans yet. I think it kind of makes sense to iterate over them, but maybe not. I mean, really, they just need to know that monthly amount, right? They should be able to answer that question. Well, I guess I'm going to say result dot count should be 1. Okay, so there's only one set. right? And then I should say result sub, well, how do I get a set out? First, yeah. First, xct eq result dot first should be, it should be a stream named income 1 with 1,001 and 12. Is that true? No, it should not. It should be a concrete plan. Concrete plans should only contain leaves. Yep. Yep. Because the and trees just add things in, and then the or trees are going to split the concrete plan, but there'll be several concrete plans, so no interior stuff. So the first is a concrete plan. Okay. Dot. Well, our plans don't hold anything, so it's kind of hard to tell. But, well, no, it's a concrete plan. If you said net for month 12, that should be 1,000 monies. And if you said, what's the net for month 13, that should be 0, because our salary only runs 1 through 12. Okay, concrete plan does not have member net yet. All right, that is true. Okay, let's go add it. Okay. Okay, so plan tree. Where's a plan tree? All right, that's good enough to fail. I almost feel like this test maybe belongs on concrete plan. But maybe it does, but maybe it also belongs outside. I think that's the case. All right, so let's add a test for concrete plan. I don't know, I'm getting too many things going, and it feels like a test for a concrete plan. That should be gone. All right, and then this. I think instead of leaf, let's make a stream. Income 1 first, last. Okay, so if I make a concrete plan and I make a stream, and then I do an add, plan dot add stream, and then I look at concrete plans. No, I just look at plan. Well, this one isn't needed. There's only one plan. Plan.net. Okay. I don't think you should really. I'm kind of getting there slow, but I think you've gotta make, I think you've got to have a plan to add a stream to it. Okay. So this test we're doing here is more the test. This is sort of the consequence. This is from the leaf perspective, but the plan itself is going to run from on actual streams, because that's all the only, we don't have pools yet. There's just streams. That's the only things you can make net income graphs and stuff from. All right, but once you have this, you have the right thing for doing it. Okay, I'm missing a brace. I'm missing more than a brace, but I don't have this method. All right, so concrete plan, we want an add method, and I think that's up here. Add, I'll say stream for now. Okay, so really this is reflecting this idea. We add a stream, and then we may add multiple streams, and then we ask for money, how much money. All right. The difference is it's going to potentially, well, how's it going to do it? So that should be fine. That should build. I don't know if we have a plan test. Plan tree test. Yeah, so I guess I'm kind of doing, I don't know. I'm deriving from the outside is what it comes down to. Multi-scenario plan has all the plans. And then how does it have them? Well, it has a plan tree. And then how's it going to work? Well, it's going to talk to a concrete plan. All right. Yeah, because we hard-coded it to return 0 for net. And we ignored add of stream. So there's nothing going on there. Okay. So now, I think we'll start with dictionary. It may be, I may have to dig in and make it an ordered dictionary for if we ever start looking at these streams, right? But okay, so what we're kind of assuming is happening is somebody's coming in and telling us add a stream, add a stream, add a stream. Now we have no scenarios, so we don't know anything about scenarios. We just know we're a plan, and you tell me there's this new stream, I should add it. Okay, so I think, well, right. I don't know. I don't want to put too much stuff in at once, but let's let the streams, well, I still don't have a good generic name for streams and pools. Let's let the items, we'll be very generic for now. Items equals map from string, the name of the thing, to stream. Okay, so no, a concrete plan will have lots of streams. See, I think this gets us back kind of to where we started, right? We had a list of streams, and dictionary. We had a list of streams, and then we plotted them, and then that was that. All right, now we're saying, let's find a way to specify bunches of streams in tree structure and plot those, and we're moving back to turning each of those into a set of simple streams. And it's a dictionary because I got to keep track of things by the name of the stream. Okay, so, and I think we can just do, we can start with items.add, well, no, items sub stream.name equals stream. All right, and this is not items.add append. what's wrong with this? Cannot assign through subscript. Oh, var. Okay, so we contain a list of streams basically, but indexed by string. So we're going to add that to the list. And then when you ask for the net, well, no, this is not a set. This is one concrete plan with basically kind of a list, but it's a dictionary. We're storing it in a dictionary. We want to keep track of those streams. All right. Now, this is not, we need to do a merge in the medium term, but right now all we have is a test with add. We don't have a merge, so I'm not going to worry about that just yet. But I'm going to add these to the streams, and then at the end, well, I almost want this, right? If you ask me for the contents at a month, right, I'm gonna do net here. Okay, so I've got the combining operator. Well, the combining operator now, there's no choices, so it's just to reduce with the items. Okay, so concrete plan. So we want to do, well, we want to do reduce money sub 0. Well, okay, you get so far and stream. And this is items dot reduce. Items dot in. And then to reduce, given so far, it takes so far plus stream dot amount. Items dot values. Okay, so I want to reduce the streams, and we're going to take stream dot amount in this month. Okay. Yeah, items. So we'll pull the values out because we care about the streams, not the names or not the pairs. Take the items values, that's a bunch of streams, and then add them up for this month. So consult each one. How much do you want to contribute? And that should do it. All right. So I think that will make this test pass. All right, I'm going to emphasize this is only one stream. Okay, and then let's do something similar. For I don't know what to call this, a revised stream. Okay, so we're going to make a stream 1 and stream 2 is going to change this. Let's change this to 10 and this to nil. All right, so we'll add stream 1, add stream 2. So now I'm driving out the merge. Concrete plans, merges, revise streams. Okay, stream 1, 1,000. Let's reduce it to 500 for month 10 going forward. Okay, so the net income in month 1 should now be 0. In month 10, it should be 500. And same for month 11. Well, let's make it month 100 at that point. Okay. So now I think this is this is making progress. All right. So we have the same stream twice with 2 different variants. So this is like our plan said salary 1, then it said salary 1 again, and different numbers. Okay. Now, again, we've got this issue about how we override and stuff like that. But I think the shape of what Concrete Plan does is not affected by that stuff. That's on stream to work out, what does it mean to merge? What does it mean to give me a, if the last date is nil or whatever. Okay. Should be 100. No, it doesn't have to be 12. Well, 12 should be 500 as well, but also 13. So we're going past the original one. Okay. Oh, you're right. Oh, you're right. This should be 0 now because we stay with the original number. Okay. So 10, 11, 12. Yeah. Thank you. Okay. Now this is going to fail, but the failure should be sensible. I think it's going to add them twice like we did before. 1500. Oh, 500. Oh, these 2 passed. Let's take a simpler case. For multiple streams. Okay, let's make income 1, income 2. All right, income month 1 should be 1,000. Month 10, this one kicks in, so it should be 1,500. 12 is 1,500, and then this is 500. Right? I think that's probably true. Because 1 through 12 should have, 10 through 12 should have both. 1 through 9 should just have the 1,000, and after 12, after 10, after 12, it's only this one. Okay. I think this probably will pass. Okay. So let's push this much. Concrete Plan can calculate sum for different streams. All right, and then let's do the same one twice and prove the merging thing. Okay, for merged. All right, now month 1 should be 0. Month 10 should be 500. And it should just be 500 here, but like you say, this one should shine through, so 0. Okay. I don't know, we may get plan tests failing. Yeah, dictionary replaced it, and that's why we saw the error that time, I think. Fatal error, expand to nil. Okay. Yeah, well, you're not a real test yet. Ignore this. Try that again. Yeah, I think this should fail because he doesn't merge streams. Well, wait a minute. I don't know. Yeah, well, no, that's the difference here is nil in this case should be saying, oh yeah, okay, that's what he's doing. Yeah, 500 forever. And we've added the same key twice, so it overwrites it, but it just overwrites it with everything. Okay, that does make sense then. Okay. But that proves we don't merge correctly. So in here, I think if the key doesn't exist, items dot contains, no, what's key? I always had to look this up. Is it just item sub key not equals nil? I think it is. Items of stream.name is nil. Then we want to do something else. We want to do something else. All right. Well, today we just do this. But I think if it's not in there, we just want to add it. That seems okay. But if it's in there, let's let original equals item sub stream.name, bang, because we know we detected that it's in there. And then let revised equal original dot merge with stream, and then items sub revised dot name equals revised, or maybe even stream dot name. I think might make more consistent sense. Okay, and keep the same value floating around, and it can pre-calculate it if it wants to. All right, so if the stuff is empty, well, I'm going to look. I think that works, but I thought there was a method for it. Subscript index for key, no. Oh, now that might work for us. Contains where self.element. That seems too hard. Okay, I think I'm done the okay-ish way. All right, now let's make sure this runs. Should pass if it wasn't clear. All right. All right, so now concrete plan merges when duplicate stream names occur. And like I said, our merging isn't quite as flexible as I want, but I don't know. It's a tricky problem. Like even just the user interface is going to be tricky. Okay, now I think that is more or less what a concrete plan needs to do at this point. It's really those, I think it's those two situations. Three. I guess you're adding a key that doesn't show up yet. Two. or you're merging a key that does. Okay. And you're building towards that final value for each item. So when somebody starts asking for net, they get all of them without duplicates or any of that stuff. Okay. That is really good. Okay, now back to plan tree. So now I'm adding, I've got my tree, and I'm hitting a leaf node, and I'm saying, where do I put it? All right, and I think what that means is we concrete plans for a leaf. I don't think it works that way. I think you have to pass in the plans. Okay, so, and I think what it should do is, well, I think it should add, I think it should add itself to anything in the list, anything in the set. Now, do I want to demonstrate that here? Yeah, I guess I do. Okay, so if you give me a set of concrete plans and you tell me every stream gets this concrete plan. Okay, so original set of concrete plans. Okay, and I guess we're allowed to revise them. Well, I guess it'll stay a set. We haven't made the test pass yet. All right, but we're changing this, and this is going to apply to the composite as well. All right, now the thing that changes, all right, so let's get PlanLeaf does not conform to plan. Right, we need to modify it up here. We don't need this part. Okay, so concrete plans, give it a set. Oh, really? Okay. Now, somebody should be complaining on the multi-scenario plan side. Right. Okay, so I think what we should do is just put in a starter plan. All right, so I think this is okay. That we're saying if you're going to create the concrete plans for a multi-scenario plan, start with one concrete plan and fill it in. All right, and if somebody comes up with alternatives, then this set is going to grow, and if they have things to add, they add it across. All right, now let's make sure. I might have a test that fails because of this. Right. Okay. But the test for a multi-scenario plan might rely on that. No, we hard coded it. Okay, this is actually better. So we hard coded the expectation of 1, and that seems right. If you've got one starting plan, and you don't add anything, it's just got that plan. I guess the assert I could add. If you take concrete plans dot first and net for month 1, it should be 0. All right, let's make sure that's true. I think that corresponds to the reduce in our thing. Okay, so make generation of concrete plans start with 1 empty plan. Okay. Right. Okay. So I think plan tree. All right, so now let's try to stop ignoring this. So we make a leaf, we start off with a concrete plan, like we have to give it something. All right, and if we do this, the result should be 1, yes, and the first and net, right. I think that should be true. Now it's going to fail because we don't do anything yet. Right. Okay, there is no first. Wait a minute. Why is that? Result.count is 1? I don't think so. I think we're returning nothing. Yeah. Okay. I don't know why it says it passed the first assertion. Yeah. Result is 0 values. I don't know why that came back 1. But maybe it didn't finish. Maybe it blew up before it could record the ones that passed or something. All right. So let's make this, well, let's let it return original first. Okay, just as kind of a step on the way. Now this should pass. It shouldn't blow up, but it won't find any money in there. Okay, yeah, 1 fail. Right. Okay, so that's not what you need to do. All right. What really should be, well, let's make this test harder. Let's give it 2 concrete plans, and then the count should be 2. Well, let's make an array equals array of result. Think I can do that? And let's assert about array dot count is 2. And then this is array 0 is concrete plan. Net 13. And then it should be true for both in array 1. Right. Okay. So it's spaced out a little. Okay. So we create a leaf based on one stream. So somehow this is our tree, is just this one little leaf that holds a stream. And we say, hey, add this to the concrete plans. And it should still have 2 plans when it finishes, but the first plan should have that stream in it, and the second one should have that stream in it. Okay. And this fails. Right. It comes up with zeros instead of actual money. Okay, good. All right. So now we're going to do original, and we're just going to modify each one. Well, it's pretty easy, right? $0.add of self dot stream. I guess I don't need to say self. Just add stream. Okay. So go through. Oh no, what does it give us? Let's say return original. Okay, so their concrete plans are classes, so they can be modified. And we're going to go through every original plan and add the current leaf to that thing. Okay, so that seems right to me. I mean, I think it's a little insight to say, oh, we're going to have a set of these. They each get it. Okay. Can add leaves, which are streams, to concrete plans. Okay. Good. All right, now, okay, let's capture that. All right, so this is build a concrete plan from a multi-scenario plan with only and nodes. And then we need one with or nodes. Okay, and this is all kind of part of the same thing here, this thing. Okay, well, leaf nodes, that's what we've done so far. Okay, so now we're going to do the and nodes. And plan tree. All right, so this. All right, so we're going to need 2 leaves. And we're going to call the make composite, make and tree. Parent, leaf 1, leaf 2. We'll put these 2, let's make them different. $6.18. Okay. So if we put in concrete plans, all right, and this should be parent. Okay. So now, again, it should fill. I mean, I'm given a set of scenarios, or I'm sorry, a set of concrete plans, which happen to be scenarios, and I'm adding stuff to them. Well, I should deal with that for both scenarios. This is in both trees. Okay, so I think this is the same. A net 12. Well, let's change it now. The net for month 1 is 1,000. The net for month 6 should be 3,000. One is 1,000. 3,000. 6. And let's add in 13. Should go back to 2,000. Okay, and I think that's enough complexity that if it's not doing. Well, you know what? I think this should really be XCT assert equal array sub 0 dot net. No. Our concrete plans don't have any quality, do they? Yeah, not really. Okay. I guess I got to do what I'm doing then. 1,000, 3,000, 2,000, 1,000, 3,000, 2,000. Okay, maybe it'd be a little better this way. So that should be a 6. Okay, so this is going to fail. Right. Okay, so plan tree. Yeah, he ignores this completely. Okay. I guess I can return original. That would be a slight improvement. And they'll have two things without the right stuff. So it'll be 0 each time. Yep. Okay. Now, it's kind of similar. I don't know. Is it identical? Well, no. It's really walking through its children, right? So I've got all my children here. And if I have any, I guess I better. All right. So if my children is nil, then I'm just going to return original. All right. But otherwise, I'm going to take my, I guess, let's do this. Guard. Let my children equals my children, else return original. All right, now I have children for each. Okay, and I want to let I want to punt to them. Children.concrete plans for given original. Well, it's really $0. And then return. I don't think original is a good name. Maybe it's result. Maybe it's just plans. Okay, so first check that we actually have my children. If we do, then return plans. I think I can write that better. Okay. Otherwise, go through each of my children and say, okay, I'm pushing it to you. Fill in your stuff with whatever you got into these concrete plans, and then we'll go from there. I think that's the right breakdown. Oh. Plans. A concrete plan with no scenarios. Which is really like and nodes only. With groups only. I call them groups in the UI. That's probably good enough. With only groups. Okay, so we throw these two things in there. Salary and expenses net 100. Concrete plans should have one plan. Its value should be 100. Is that okay? But I guess my plan tree one may have passed. All right. That's an old. Okay. So the real test was plan tree, this stuff. So he did go ahead and add the things. All right. Just running tests again. I wish this would reset itself properly. Okay, so make an and tree group, add its children to all plans. All right. So that is this. Unfortunately, we can't really see it. We really need to graph the scenarios. And maybe that would be a better next step. Graph scenarios from the concrete plans. Now, what I'd like to do, I mentioned before, I've got all these ideas for ways to make it easier to make sense of those scenarios, but I don't know if we need to. Let's see, we don't really have time to start it anyway, but the next alternative is build the concrete plan with OR nodes. And I think the challenge there, well, the first challenge is we don't distinguish AND nodes and OR nodes, so we have to distinguish them first. Now, we could either put something in the kind of a type field, right? So we have plan tree. Let's do that. Plan tree makes two nodes. They look exactly the same, except one uses max and one uses plus. And I think if we start graphing from the concrete plans, we don't have to worry about max because they'll have multiple pictures and they can see what the max is for themselves. All right, so one way would be provide a type that's like, are you an AND tree or an OR tree? And it could be a Boolean or an enum or something. I suppose we could ask Leafs to provide a type for themselves, which might work okay. Another alternative would be to break this apart again, which we were there at one point, I think. We had an AND maybe it's an and composite and an or composite. Um, or I don't know if we said alternative, plan alternatives, plan groups, plan scenarios, plan groups. I don't know. Make two separate subclasses. So basically, the subclass, when it goes to do concrete plans, this will be the implementation for the and tree, and then the or tree will basically take every plan and multiply it by the number of children in sort of an interesting way. I don't know. This could get a little tricky. It's going to need to make copies of those concrete plans, right? We can't all be modifying the same one because there's supposed to be alternatives. So this guy is a little tricky. Yeah. So a little more work for the next one. All right, but I'm glad where we are. This is good. So we made progress that we fixed the graphs. Where is that? All right, so we made the graphs look at PlanLeaf, look at the streams, not by their month, not just take the whole value. Then we added merging, flip stream to a struct, boring, remove dead code, boring. But the two big things were making it so concrete plans, we drove out concrete plans with these leaf nodes and enough stuff to get them going. So we have the add stream and the net from the stream. And those now will populate. If there's a set of concrete plans, the leaf nodes add themselves to everybody in that list. If there's an and tree, it takes those same plans and says, hey, children, add yourselves to these plans, whatever they are. And we also set up an initial plan. You start with one plan that you're working on, and then you can add to it if you need to. So this is good. Tomorrow will be a good day too. We'll handle trees of alternatives. And I hope we finish that tomorrow. We'll see. That's going to be a little bit bigger. And maybe, I don't know. I'm going back and forth on this now, aren't I? Yeah, I think I am. All right. Well, anyway, thanks for joining me today, and hope you can make it at a time in the future, 2 to 4:30 Eastern or 6 to 8:30 p.m. UTC, and I'll see you tomorrow. Bye bye.